warm welcome to our month-long celebration of the Science Festival, which will finally culminate on 24th September with the Mars orbital mission. We at Rajya Sabha TV have been bringing you a series of programs related to science exploration and research which concern you and me in day-to-day life. Today is a very special day. Just a few days are left for the Mars orbiter mission to accomplish its mission actually, and we are at a very special place, that is the Indian Space Research Organization in Bangalore. This is the very place where the satellite was fabricated, and this is the command center which is controlling and navigating the journey to the red planet. But what does this journey mean for India? What does this Mars mission entail globally, and what are the kind of challenges which the scientists have faced in putting up this humongous project? Joining me now is an esteemed panel of guests which I'm going to introduce to you now. Next to me is the project director of Chandrayaan and who is now currently the program director of the Indian Remote Sensing Satellite and Small Satellite Systems, Dr. N. Annadurai. Then we have Mr. S. Arunan, who is the project director of the Mars Orbital Mission spacecraft. And then on the extreme, we have Dr. Keshav Raju, who is the mission director for Mars Orbital Mission. Welcome all of you on this special program on Rajya Sabha TV. To begin with you, Dr. Annadurai, what is the current status of this entire project at the moment? If I could ask you to explain in one line, what is the status of the project right now?
No, presently look at here, the Mars Orbiter mission is en route to the Mars, and it has crossed more than 90% of the travel towards the Mars is concerned. And
so can we say that the journey has been successful in terms of percentage so far as you look?
Yeah, percentage wise it's successful, but still the final culmination of going around the Mars is the day, the D-Day is September 24th. I think towards that I think we are eagerly waiting, and as of now the mission is doing fairly well, and we hopefully will able to do the first attempt.
So no signs of nervousness or palpitations increasing at the moment?
Yes, obviously anxiety is the part of the game. Okay, otherwise any exploration of this nature without anxiety not possible, but we have prepared everything well. The team is working fairly well towards their success.
Mr. Arun, if I could come to you, what are the kind of challenges which the scientific community has really faced right from the inception and to the final D-Day? What are the kind of challenges which you've really faced?
The major challenge of this mission could be making of the spacecraft. The system specifications, derivation, which should meet the interplanetary requirements fundamentally. That was one of the major challenges at the inception of the and construction phase of the satellite.
Okay.
And parallelly, the key element in the mission part could be this our ability to predict. Here, most of the things
ability to predict
the satellite under various influences of Earth, Sun and Mars, their disturbances. When the observation and prediction matches, probably that is one of the key elements of the success in this mission.
But is it what you're saying, is it in terms of that there were various orbit raising maneuvers which happened in phases? So was that a big challenge for the community?
It is also one of the challenges, I must say, but prediction part, the behavior of the satellite under the influences of various galactic forces, and which determines its position and velocity and its orientation towards the planet. And the predictions are better now. So with this mission, our ability to predict for spacecraft this kind has really matured, which shows that we have completed 92% of the journey successfully with a good prediction of this position, velocity and its orientation towards Mars. So
but after the orbit raising maneuvers have happened, then you have the trans-Mars injection.
True.
TMI, which people say that it's a mother of all slingshots.
Exactly.
Why do you say that?
The trans-Mars injection, where the specification for that kind of transfer to happen with respect to satellite systems are very stringent.
Okay.
Compared to what we are going to do in the insertion phase.
Right.
It is one order higher in the trans-Mars injection.
But what is the technical difference?
Difference is you have to orient yourself, that is you are putting the spacecraft in the plane where Mars is traveling.
That is the heliocentric orbit you are talking about.
So around the Sun, you are going to put the spacecraft in the path where Mars planet is traveling. So the aligning your plane of injection out of the Earth with respect to the Mars plane is so critical. So it has to follow the trail of the Mars. So that becomes most complicated when it comes to transmass injection, where the specification corridor with which you have to leave the Earth within a specified time and with a specified angle are more important, which puts a lot of constraint on the spacecraft's attitudes and burn strategies which we adopt to leave Earth becomes more stringent compared to what we are going to do in the Mars orbit insertion phase, where it is a bit relaxed.
Dr. Keshav Raju, if I could come to you, a question from a layman's point of view always is that when you shoot a satellite in space, how does a satellite really find its way? Because on road, if you are traveling, you have various landmarks to follow. But what kind of landmark does a satellite follow? And especially with respect to the Mars orbiter mission, what are the kind of landmarks which probably this satellite would look for?
See, at every instant, it is very important to know what is the spacecraft position is in some frame of reference. For that to determine, we collect the range data from a ground station as well as the Doppler data, which tells its position as well as the velocity information.
And this is a constant process which is happening like 24/7.
Most of the times, we will be collecting these data and using these data from the various stations, it is possible to determine what is the position of the spacecraft.
But what kind of challenges do you really see when you talk about this kind of a navigation? Because there would be times when probably you would not get data, or maybe one or two Earth stations would go wrong with their data. Then how do you really correlate then?
The challenge is what is the accuracy of this data that we are getting. For example, the Doppler data, we need to get an accuracy of about 2 millimeters per second. Even a range also of that order of 1 or 2 meters. Unless your the data systems where from we are collecting these data, the acquisition systems, unless they are accurate enough to provide this type of figures, it is not possible to find out the spacecraft position accurately.
But scientists have also been talking about a black hole period where probably you would not see the satellite. Just explain us a little what exactly that period is all about.
So the blackout period, for example, we all know that the Earth and Mars, they are revolving around the Sun. So during some part of their revolutions, the Sun is in between of the Earth and Mars. So when Sun comes in between the Earth and Mars, the communication is originated from the Mars that has to pass through the Sun to reach the Earth. So at that time, we get the communications will not reach properly.
Okay.
So that is what is called.
Basically, it's a zero communication period for the
zero
scientists at the
communication
control
period
room.
for about 14 to 15 days.
And you're also not able to see the satellite at that moment.
Of course, satellite anytime we cannot see. We had to see the satellite through the communications only. The communication itself gets interrupted during this time. So that is where we had to make this spacecraft to survive on its own during this blackout period. As we cannot give the maintenance commands from the Earth, it is not possible. So that is where it becomes a complex part to make this spacecraft to survive on its own during these periods.
But Dr. Anandurai, one question which comes to mind is that when you shoot a satellite, then there would be chances probably that, you know, after immediate shooting of the satellite into the space, and if anything goes wrong, then what are the contingency plans which are in place? Supposing if it doesn't work for the first half hour or 40 minutes, what do the scientists really do then in the control room?
Yeah, typically of any mission we will have the contingency plan already worked out. In case something in nominal,
which is documented from
documented
prior.
properly, people have trained in the ground how to react for that. And then nominally we will have something called redundant system. Something main is a problem, redundant system, or main operation is a problem, redundant operation plan, something like that we would have. But this particular mission of Mars, we cannot keep doing all the time. The Mars is going all the way and you have the communication time. Near Earth missions or even the communication mission, within a second we are able to see and react. But this mission, such thing is not possible. We are talking about nearly 20 minutes, 30 minutes time delay.
Right, because of the huge distance from the Earth.
Yeah. So because of that, it is basically we have the a transition period wherein work as if near Earth mission, where the people are watching and commanding, and slowly making the satellite to be aware of, and a built-in a fairly good number of autonomy has been built in this mission, and this sees something is now nominal main path, and it is able to go to the redundant path. So that way this mission is built-in capabilities of ground-based systems wherein the people are trained and have the plans are available with them.
And which
as
is
long
why
as
also
around
probably you don't take chance just with one Earth station. You have various Earth stations which are giving you a data.
In terms of ground system, in terms of manpower, in terms of machine, in terms of communication link, in terms of the system sitting on the satellite, we have
all that is
a lot of
together.
redundancies are in place.
Dr. Annadurai, I'll have to take a small break here, but when we come back, we talk about the objectives of the payload or the experiments which are being carried out by this Mars orbiter mission. Back in a moment. Welcome back. You're watching our special program Mars and Beyond from nowhere but Indian Space Research Organization in Bangalore. Mr. Arunan, if I could ask you, there are various experiments, 5 payloads which are there carrying out various objectives. What are these experiments all about?
Fundamentally, we have a spectrum of payloads in our mission, which does the planetary science experiments with respect to the surface topography of the Mars, and with respect to the atmospheric studies, and with respect to the methane part of it.
And these instruments which are there as part of the payloads, these are all indigenously made?
All are indigenously made, and they are developed at various centers of ISRO, where planetary science people are working on that. So these payloads cover a wide spectrum of observations which are necessary for a planetary science experiment of this kind to explore Mars.
But there's a lot of curiosity as far as sensing methane is concerned. The methane mystery people are talking about. Just tell us a little about it. Because people always keep comparing it with Chandrayaan-1 where it found droplets of water. So now people are saying that there's a lot of curiosity whether you would find methane with this experiment. What is the scope of success with this?
See, it is, as you know, that methane is a fundamental building block for life.
Right.
Okay, that's the first part of it. So whether life existed in Mars or was it like Earth once upon a time, and our Earth also will become like Mars once we start misusing that. So these are all the questions probably fundamentally answered with respect to existence of life, for which methane is an essential component. So the finding methane is basically to have an exploration for the life science part of it in the Mars planet,
Right.
where the content of the methane, during the radio telescope from the ground observations have found out some kind of values in terms of ppm we call it. So we also carry an instrument which is quite sensitive enough to detect methane. Probably if we are with the sun activity at a particular period of observation and with the instrument sensitivity, probably we should be lucky enough
But
to
so
have.
with the kind of closest distance which the satellite will go towards Mars, or the closest distance is going to maintain, you're hopeful that you would get some kind of a data on methane
Yes, we are
sensing?
hoping to get some data on the methane content from the instrument which we are carried. Probably ground observations, the instrument had an opportunity to observe ground,
Right.
from which we could say what is the content of the methane in the Earth as a reference sphere. Already that reference value is in the database. Probably we will compare with Mars methane content in terms of ppm and be able to correlate the data and see that the quantum of methane can be estimated.
But what about this water vapor mystery? Are you also hopeful of getting data on that as well?
True, exactly. There is a loss of water vapor process which is happening in the planet over a period of time. So the instrument which we carry, a Life and Alpha photometer, which measures the deuterium by hydrogen ratio,
Okay.
which is quite an index to know the rate of water vapor loss from the planet. We could estimate, probably we can construct a model saying that what could be the water content this kind of billions of years ago, what would be the rate after which. So the water loss which is happening is a continuous process from the Mars planet, can be explored by that
Probably we
instrument.
could have some kind of a data as to why Mars looks so desiccated.
True, exactly. What is the rate of loss of water vapor can be estimated, from which we can make a model and see that how long will this process happens to make it right.
Dr. Annadurai, I was asking you that there's something very interesting, that you're giving so many instructions, we're looking out for so many experiments. Do you really pre-program everything before the satellite is shot, or you have to keep giving instructions? What is the process like?
I think because the mission of this nature, it calls for interactive communication is not possible all the time. So this mission is basically designed such that you pre-program the systems, how it should operate, either in terms of the maneuvers, in terms of its journey, or in terms of its operations of the payloads, and even the way in which you go download the data. Things are all pre-programmed, and the majority of them already have ground tested and many times.
So when you pre-program, then you have to have a special software probably for that, it starts detecting methane, then it starts sensing for water vapors?
Not to that extent. Basically, it is it will be able to operate which portion of the around the Mars when it's going around. Okay. Each one of the instrument has its own optimal look.
Right.
In the Mars are looking for the atmosphere, or looking for the space, into the space. Its own way it is being designed.
Right.
And that particular time it comes as per the pre-program, each one of the instrument will be operated.
Okay.
And the operated data, once the data whatever collected will be stored into a tape recorder.
Right.
And in the subsequent
and then
moment
it
will
starts sending
the
data
ground.
to the control
And the majority of the interpretation will be done by the ground scientists who are sitting in the ground.
Okay.
Okay. Basically, mostly it is trying to get the first-hand knowledge about
Right.
Mars atmosphere and the space like that. But otherwise, most of the interpretations of correlating the data and trying to interpretations will come from the ground.
Raju, if I could bring in you, when we're talking about these experiments, we also have a special Mars color camera which is loaded as part of the payloads. Talking about the resolution of the camera, because each time the camera sends a picture, maybe because of, on Mars atmosphere or the surface of Mars, are you hopeful of really getting very talking about specifically about the resolution, are you really hopeful of getting very clear pictures?
See, here the distance is varying with respect to the
Right.
Mars surface.
Right.
When the spacecraft comes to the periapsis location, it can view the surface within a distance of around 500 kilometers.
Right.
So there it will be in a position to give around 25-meter resolution.
Okay. Okay. And which is in terms of the scientific community, you would say it's quite clear. It's quite
clear.
precise.
Yeah, precise.
Okay.
And we also have the option of taking the imageries, the total Martian disk in a single snapshot. So the different resolution imageries are obtainable due to the orbit variations.
Right.
From low altitude to a very high altitude.
Right. And you would get various layers of atmosphere, or you're just looking at the outer layer of the atmosphere probably? The pictures.
Atmosphere, basically some of these payloads, they study the surface. The other like deuterium, Lyman.
Okay, that probably would look at the inner
That look at the
layers.
atmosphere.
Okay.
MSM will look for the atmosphere. So each one has got its own application. Some of them are for the atmospheric studies, like the methane sensing, and what is that?
Neutral atmosphere sensor.
The
other one is for the surface studies. The third one is for the thermal infrared sensing.
Okay, okay, okay. Dr. Annadurai, what kind of, Mars orbital mission, of course, is for the technologists, for the scientists, is a very big challenge. But what about the student community, and what about India as a nation? How does this community benefit? How does the country benefit basically out of this Mars orbiter mission?
Yeah, you recall the Indian space program is predominantly identified for the societal needs, but it has another aspect also to enthusiast the younger generation to be a part and parcel of Indian science program. And over and above that, this being funded by basically by the government of India and the people's money, people also need to be aware of what we are doing. So that you look at here, before Chandrayaan versus after Chandrayaan. After Chandrayaan, definitely fairly good number of Indian youths and youngsters are aware of program.
But Dr. Annadurai,
Same thing,
when you talk about Chandrayaan,
Yeah,
Chandrayaan actually did something which has not been attempted by other nations. And you know, the critics always say that with the Mars orbiter mission, India is actually treading onto a well-trodden path, which has already been, a lot of it has been accomplished by US, Russia and the European space agencies. So how would you really counter that?
Yeah, that's, you look at here from Chandrayaan to this, I'm telling about somebody graduates and postgraduates.
Right.
So planetary science point of view, you look at here, Moon is only nearby system, and when you're going to the Mars, is the next thing. So we are graduating towards the outer system is concerned. And even there, like what happened the Moon, even the Moon, we are the 70th people to go to the Moon.
Right.
But we are the first people to unambiguously answer what are on the Moon.
Right.
So similar way, even though Mars has been explored a fairly good number of times, I think still lot more question marks are still there. Methane is there or not, and things like that, whether life was there or not. These questions were still lingering around.
But then the question is that US also has its MAVEN position 2 days earlier than MOM is going to be. So, and the goals are common. So, probably MAVEN is also doing the same thing which MOM is going to do.
No, if you really look at overall science aspect point of view, there are two different missions. And as rightly told my colleague, this is the mission where we are giving a closer look at the Mars and as well as going for the further ring. And over and above that, we have our own thing. It is not we are somebody is going before that. We are not. We are also not trying the case. We have identified our own goals of what we can do, what we can be achieved, and we say considering the available resources, considering the available schedule with our talents, and we are able to show yes, we also can. We can do a fairly
but
good
talking
amount
about the USPs of MAVEN and MOM, what would you say is MOM's USP probably?
Okay, MOM point of view, if you look at
because
here,
people are looking at it as if the goals are common, but the end benefit, or probably in terms of what they're going to achieve, is that going to be different?
now you look at here when you are looking for the moon, when you are looking for the Mars, on the planetary system being a common, everybody observe, every scientist look for that thing. But everyone would like to have their own way of looking the systems and trying to infer the systems in a different way. And history talks very well when a time, even though explored places and re-exploration when we are doing, definitely something new has come out. It has happened. History has talked about that. I think we are hopeful of that. Similar thing will happen in the Mars orbiter mission also.
But Mr. Arunan, talking in terms of technological spin-offs, the immediate technological spin-offs, what are you actually looking at it?
So, first and foremost, which I told, is a communication system which is very vital for the interplanetary missions, wherein you have to communicate with an object which is something like 400 million kilometers away with respect to Mars mission. So, we should have the system first time demonstrated successfully, which can form backbone for future missions of ISRO for interplanetary purpose. Second could be the full scale autonomy features which needs to be incorporated for such a mission where a micromanagement of the mission is not possible in the real time. That also we have incorporated a full scale autonomous system wherein satellite itself can take care of the faults and satellite itself can execute the commands which are pre-programmed on a time-tagged manner, has been well demonstrated and well implemented. And third could be the propulsion system which is required to propel you out of the Earth gravity and get inserted into another planet of Mars, wherein the a bigger engine needs to work after a dormant period of 300 days. Also is one of the major technology feature which first time we are implementing, and those 300 days of demonstration though we have done in the ground, it has yet to be demonstrated in the insertion phase. And fourth could be that power systems which, because of the distance of the Mars from the Sun is so large, from 1.5 Armstrong units, the solar intensity for a satellite operating in that planet comes down, which means we have to have a separate scheme of a solar panel to account for the reduced solar intensity and generate the required power to keep up the spacecraft systems. That is also one of the major challenges, I will say. And
so basically, in terms of if God forbid if nothing happens, the kind of systemic failures you're looking at probably is a failure of a pump or a valve.
Yeah, the pump or a valve can malfunction, a valve can fail to open, and a non-metallic part, some non-metallic parts in the valves can swell up and cause an issue. All these issues, probably we have done enough ground tests to demonstrate successfully.
So the chances of failure basically are minimal.
Almost, I will
and
say
as
it is
Dr. Ananda Roy has already said that more than 95% of the job is done. But remember, every long journey has the first step, and which is full of hope, and that is what everyone is hoping, that the mission should be successful. And all probably what we can say is keep going, Mom, and that is the message on the Facebook page of ISRO as well. We're really running out of time. Thanks to all my guests, Dr. Ananda Roy, S. Arunan and Dr. Keshav Raju. It was a pleasure having you on our panel discussion.
Thank you.
Thanks.
Thank you.